Hello everyone, welcome to the second video on for loops. So let's start with a brief recap of what we were talking about in the previous video. So again, I'm going to start by creating a script. And remember, we had said something like for I equal to 1 through 10. Let's say I want to just display I. So then again, let me save this as my script, let's say. And I can come back, whoops, wrong direction. I can come back, I can run my script, and this displays 1, 2, 3, 4, all the way up until 10. So the first thing that I want to emphasize is that if we go back to our script, there really wasn't a rule saying we need to use the colon command here. What I mean by that is we could have just as well said I equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going to work exactly the same. So I've updated my script. Let's run it again. And we can see I get exactly the same output. So there's no reason to type all of this out by hand. Using the colon command is definitely better. But I wanted to show you that just to emphasize that when we're making our for loops, we can really put whatever vector we want here. It doesn't have to use the colon command. So maybe just another example so you can really see this is, let's say I put in the vector 10, 5, 6. And I'm going to leave this display I alone. Now take a minute and think about what you think is going to happen. So we have I equal to 10, 5, 6, and maybe something different that I want to try is instead of displaying I, let's actually do display hello world. So again, take a minute, think about what's going to happen in this case. So again, we've updated my script, and we can see that hello world gets printed out 3 times. Now let's see why that's the case. So if we go back to the script, the way we go through this for loop is first we say, okay, I is equal to 10. Then we display hello world. Then we go back up and we say now I is equal to 5. Display hello world. We go back up. I is equal to 6. And then we display hello world. So because nowhere kind of inside of this loop do we put I anywhere, basically the value of I has no bearing on what gets displayed. All that matters here is just the length of the vector. So if I were to put even like, let's say like 10 here, what's going to happen is we're just going to print hello world one more time. So another thing that we could do is we could say something like, okay, well now let's say the variable j is equal to I plus 2, let's say. And I'm not going to put a semicolon because I want us to see how j gets updated. So I'm going to say Control S, save. Let's run our script again. So now we can see, okay, first we print hello world, then j is equal to 12. So how did we get that? Well, first I is equal to 10. We display hello world, then j is equal to I plus 2. So 10 plus 2 is 12. So that's where we get 12. Then I is equal to 5. We display hello world. J is equal to 5 plus 2, so j is equal to 7. And we continue that until we've done I equals for every entry in this vector. So one thing I want to point out here is notice that I is not changing. And if I had I plus 2 by itself here, I guess what I wanted to say was if I have I plus 2 like this, it's not actually changing the value of I. So just as an example, let's save this code. I'm going to run my script again. So we print hello world, then we have answer equal to 12. That's because we're doing 10 plus 2. Then we would do 5 plus 2, 6 plus 2, 10 plus 2. But if we wanted to change I, we would have to say something like I equals I plus 2. But let's go back to j. I'm going to save it again. And I want to maybe show you how we would have to do this by hand if we didn't know about for loops. So let's make a new script here. What I'm going to do is first I is equal to 10. Then we display hello world. And then if we look, we see then j is equal to I plus 2. So then j is equal to 12. So that's the first time we go through the for loop. Then we update it. We say that I is equal to 5. Then we display hello world. Then remember j is I plus 2, so j becomes 7. And now we update I, so I becomes 6 now. So then I is equal to 6. Then we display hello world. And j is equal to I plus 2, so it becomes 8 in this case. Then we see after 6, I becomes 10 again. Oops. So I becomes 10. We display hello world. And j is equal to 12. So now I'm going to save this as my script 2. And what was the point of me typing all of this out? As when we run my script 2, I want to show you that this gives us exactly the same as what we had written in this for loop. And I want you to appreciate how the for loop was able to do in 4 lines what took 12 lines over here. So let's go back to the command window. Let's run my script 2. And we can see here, oops, where does it start? First it's hello world, then j is equal to 12, 7, 8, 12 again. Versus if we run our original script, you can see we get exactly the same thing. So last thing I want to show you in this video is, as we've said a number of times now, functions are much more important for us moving forward in the class than scripts. So let's do one more example where we have a for loop and a function. So I'm going to create a new function. Let's call it squares. And what I'm going to do is I want to define a function that takes as an input n, and as output returns a vector v that has the first n numbers squared. So if it's 5, I have a vector that goes 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So let's refresh and review the original way that we did this. So I'll write here, this is the original method, is we would say, first we're going to say v is equal to the vector that goes 1 up to n. Oops. And then we say, well, v, take all of the elements and square them. And remember, the dot means do this element-wise. So I'm going to save it. I'm going to call it squares. And now if we go back to the command window, if I run the function squares of 5, this gives me the squares 1, 4, 9, 16, and 25. So like I said, that's a little refresher on how we typically would do it. But now let's see a new way. So I'm going to make a new function. Let's call it squares new, or new squares. It's still going to take n as an input. It's still going to have v as an output. But now I'm going to show you, so let's call this method 2. This is a very common syntax for starting these kinds of problems. I'm going to say v is equal to the empty vector. The reason for this is we're going to add elements to v. So think of v as just being like a template, a blank vector that we can add entries to. Then what we're going to do is we're going to say for I equal to 1 to n. We're going to take our vector v, and again, this is very important notation. It's going to be v, comma, and then we're going to put I squared. Now, what this means is we're saying take v, and we're going to keep we're going to keep v like the same, basically, and we're just going to add an element to it. So in this first iteration, let's say I equal to 1. So v is currently empty. Then we enter the for loop, and we say, okay, keep v empty, but now add on 1 squared. So it's going to be v equal to just 1, the vector that only has 1. So then I'm going to end the for loop. And let's see, why is it not happy with here? Don't worry about that error message for now. Let's just save our new squares function and run it. So here I've done new squares of 5, and we can see this gives us exactly the same as our original squares function. So I think this is a good place to end this video. As always, let us know if you have any questions, and we will see you in the next video.